In this lecture, we are going to discuss about number system conversions, and we will be going to cover the following conversion of bases. First, we will discuss about binary to decimal. Then second is hexadecimal to decimal, and third is octal to decimal. So among all the 12 conversions, we are discussing 4th, 7th and the 10th conversion, and the common point in all these three conversion is we are converting from any other number system to the decimal number system. For example, binary to decimal, hexadecimal to decimal, octal to decimal. So we are converting to the decimal number system from any other number system. So first is the binary to decimal conversion, and here we are going to use the sum of weight method. So in the first lecture of number system we have discussed about weights, and we have discussed about binary weights, octal weights, hexadecimal weights and the decimal weights. So what we do here, we multiply each bit in the binary with its corresponding weight, and after all we are adding all the results of multiplication, and finally we get the conversion from binary to decimal. And we have discussed that the binary weights are assigned for the integer values. They increase from right to left, like rightmost bit that is having the weight that is 2 raised to power 0, and as we traverse from right to left, the binary weight keeps on increasing from 2 raised to power 1, 2, 3 and so on. And for fractional binary numbers, the binary weights, they are decreasing from left to right. As we traverse from left to right, the weights are 2 raised to power minus 1, 2 raised to power minus 2, 2 raised to power minus 3, 2 raised to power minus 4 and so on. So here before the decimal point we can see the weights are increasing 2 raised to power 0, 1, 2, and after the decimal point the weights are decreasing 2 raised to power minus 1, minus 2 and so on. So we have already discussed this decimal to binary conversion, and here we have used the method that is called as the repeated division by 2 and repeated multiplication by 2. So for this part of number 1259, we have used the method that is called as the repeated division by 2, and here we write quotient, here we write remainder, and keep on dividing the quotient value with 2 until and unless we get the quotient 0, and finally we record all the remainder values starting from bottom to top. And for the number that is after the decimal point, we use the method that is repeated multiplication by 2, and we extract all the values that is before the decimal point as an answer, and we write it from top to bottom. So already we have done this conversion. Now what we do, we need to convert binary to decimal. So we take a result of binary and we convert it back to decimal. So how to convert? This is the binary number and we need to convert it to decimal. So what we do, we write the binary weights on every bit, like the binary weight for this bit is 2 raised to power 0, 2 raised to power 1, 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 8, 2 raised to power 9 and 2 raised to power 10. And here we have 2 raised to power minus 1, 2 raised to power minus 2 and 2 raised to power minus 3. So what we do, we multiply each bit by its corresponding weight. Like first bit is 1 and its weight is 2 raised to power 10, and second bit is 0 with its weight 2 raised to power 9. So we multiply each bit by its corresponding weight, and finally we add all the values. So we get the first part of result as 1259, and for second part the weights are 2 raised to power minus 1, minus 2 and minus 3. So we multiply 0 with 2 raised to power minus 1, next 0 with 2 raised to power minus 2 and 1 with 2 raised to power minus 3, and finally we get the second part of the result, and then we combine the two results to get the overall result from binary to decimal. And second method of conversion, that is the hexadecimal to decimal. Again we use the same method, that is called as the sum of weight method. The only difference here is, here we are converting hexadecimal to decimal, and in the hexadecimal the weights are in terms of 16 raised to power 0, 1, 2 in the increasing order like this as we traverse from right to left, and after the decimal point they are in the decreasing order as we traverse from left to right, 16 raised to power minus 1, minus 2, minus 3, minus 4 and so on. So what we do, we multiply each hexadecimal digit by its corresponding weight, and finally we add all the multiplications to get the overall result. For example, we have done this conversion, that is decimal to hexadecimal. For this number like 1259.125, if we need to convert it to hexadecimal, so we use the method, that is the repeated division by 16 method. We get the result here 4EB, and for second part we get the result as 0.2, because when we multiply it by 16, here we get the result as 0, so we stop here and we get it as 0.2. So final result we are getting for decimal to hexadecimal, that is 4EB.2. Now what we are doing here is, we are converting hexadecimal to decimal, and for hexadecimal to decimal conversion we are using the sum of weight method, and here the weights are assigned as, for this particular digit it is 16 raised to power 0, for this digit it is 16 raised to power 1, and for this digit it is 16 raised to power 2. So we multiply 4 by its corresponding weight, that is 16 raised to power 2. Then E equivalent value is 14. So we multiply 14 with 16 raised to power 1, and B corresponding decimal value is 11. So we multiply 11 by 16 raised to power 0, and finally we add all these multiplications and we get the first part of result. And for the second part of result, the weight assigned here is 16 raised to power minus 1 after the decimal point. So we get the second part of result as 0.125. So we combine this part and this part to get the overall result. And third is the octal to decimal conversion. Here again we use the sum of weight method, but here as it is octal, so weights are in the order 8 raised to power 0, 8 raised to power 1, 8 raised to power 2 and so on. They are in the increasing order as we traverse from right to left. And for the fractional numbers, like for the fractional hexadecimal, they are 16 raised to power, it should be octal. Now for fractional octal numbers, they are in the order 8 raised to power minus 1, minus 2, minus 3 and so on. So they are in the decreasing order as we traverse from left to right. So already we have done this conversion, that is decimal to octal, by repeated division by 8 and repeated multiplication by 8. So we get the result as 2353.1 with the base 8. Now what we do, we take this number as input and convert it back to decimal, and the method here is, that is the sum of weight method. So first part is, that is 2353. Now what is the weight assigned to this particular digit, that is 8 raised to power 0. For this digit it is 8 raised to power 1. For this digit 8 raised to power 2, and for this digit 8 raised to power 3. So we multiply 2 with 8 raised to power 3, then 3 with 8 raised to power 2, then 5 with 8 raised to power 1, and 3 with 8 raised to power 0. And finally we add all the multiplications, so we get here the first part of result. And for the second part, the weight here is 8 raised to power minus 1, so this is the second part, and this is the overall result we are getting. And this is the worksheet for practice. You can practice by taking this binary as input and convert it to decimal. Then take this hexadecimal as input and convert it to decimal, and take this octal number as input and convert it to decimal. And you can verify these results. These are the references I have used. Thank you.